Educational Communications and this station present Environmental Directions with Nancy Perlman. On this series, we explore the effects of human influence on the Earth's ecosystems and discuss solutions to environmental problems which affect the quality of life on this planet. Environmental Directions gives you the kind of information you need to help you participate in decisions impacting your community, the nation, and the world. Now, here's your host, Nancy Perlman.
Hello. For the next half hour, we are going to be talking about microplastic pollution and removal technologies and biodegradable alternatives with my guest, Dr. Shababa Selim. She is a senior technology analyst with ID TechX, a marketing intelligence firm. She has also been an applied science consultant with a focus on product development and technology innovation for small and medium enterprises and large multinational corporations. She has done much research on many different topics. Welcome to Environmental Directions.
Thank you very much, Nancy. Pleasure to be here.
You have been very extensively involved with this recent research project that your company has created there in Cambridge, the United Kingdom. I'm talking to you across the pond, as we say.
Indeed.
The topic is how you examined biodegradable plastics and polymers. But first we have to describe the different kind of microplastics versus the plastics that we're very familiar with, like plastic bags and plastic plates and plastic bottles. Plastic is in our society everywhere. What's the difference between the regular plastic that we might be more familiar with and the microplastic?
That's an excellent question. So the definition of what constitutes a microplastic may vary depending on where you look. The general consensus is that microplastics are essentially solid particles that typically have a diameter of 5 millimeters or less. You mentioned plastics that are ubiquitous through our daily lives. So there are two main categories of microplastics. One is the microplastics from the very plastic products that we have. So these are secondary microplastics. And these essentially form from the breakdown of those large plastic items. For example, if you have a plastic cup and at the end of life that starts breaking down, eventually it will break down into smaller and smaller pieces, so it will become microplastic. And then you also have primary microplastics. Now, these are purposefully manufactured, so they're typically used as functional additives in various products. So one key example would be back in early 2010s, you had a lot of toiletries having microbeads in as exfoliants, for example. But that's just a very small amount. But you have various other industries and products that use primary microplastics as functional additives in paint, in cosmetics. They're used as fragrance encapsulants, or even in agricultural products. You have seeds that are coated with plastics, so they act as controlled release agents. So they're used in various products across several industries.
How serious is the microplastic pollution in comparison to the loss of ecosystems, climate change, and all the other environmental issues?
Personally, I would say it's up there. It is very serious. I mean, microplastics have been found in the remotest of locations. So they are highly mobile, and once they're in the environment, they can be mistaken for food, they can persist, they can bioaccumulate, and the full extent of the implications of microplastics bioaccumulating is still not fully understood. So it's something we definitely need to do something about, act globally to control this issue.
I have heard that the plastic does break down, as you say, into tinier pieces, eventually these microplastic pieces, but they're unhealthy, and we even have them in our own bodies, and animals that are wild are getting them, and it's not healthy for us. How tiny do they get, and how unhealthy is it?
That's, again, a very good question. So when you have mismanaged waste, these second microplastics form, and you can have microplastics, which are how we define them as 5 millimeters or less, but again, they can continue to break down, and you can end up with nanoplastics. So those are even smaller than microplastics. So that breakdown continues over time, essentially. In terms of hazards, these microplastics, once they're in the environment, the physical particles, they can bioaccumulate. They can get mistaken for food, when they're in the ocean for fish, for example. But microplastics can also act as carriers for chemicals like heavy metals that are already present in the environment, or they can act carriers for other persistent organic pollutants or biological agents. There are a lot of concerns around the potential hazards of microplastics, but the issue is also that there isn't a lot of conclusive studies out there that can quantify these risks for a long period of time. So that's really an ongoing area of research at the moment.
We are so surrounded by plastics. A lot of the food comes in plastic containers here in the United States, and other products come in plastic, and I look at the bottom what number plastic it is, 1, 2, 3, 4, 5, with the little recycle symbol. And these companies make it sound like, oh, this is recyclable, but basically only number 1 and 2 are getting recycled, and that's less than 5-10% of the plastic that we get and use gets recycled. Is it the same in the United Kingdom and in Europe in terms of how much regular plastic is being used and recycled?
I'm afraid, Nancy, I don't have the exact figures for you there.
That's a scientist for me. You want exact figures. Tell us in general how much plastic is out there not getting recycled that obviously would be breaking down into these microplastics that you are researching.
I may be able to kind of give you some figures. There was a study a few years ago now. For example, the projections were that at the end of life for plastic products, you would have in 2025 expected to be around 400 million tons of plastic waste. Now, around half of that gets landfilled, but let's say probably around 20% would be mismanaged, and this then ends up being leaked into the environment, leading to probably secondary microplastic generation.
You are based in the United Kingdom, London, Cambridge, and you're doing market forecasting, but is it different in the EU, over in Europe, over in the United Kingdom versus the United States?
So we do market forecasts, for example. A lot of our forecasts are 10-year forecasts, and that is usually global forecasts. So we look at how the market has historically grown, what factors are impacting the market, what trends are up and coming, and we build all of that into our models to build 10, 20-year forecasts for different technologies. And in some cases, that can also be, segmented by different regions. So looking at players in the EU versus players in the US or Asia Pacific, it depends on the market we're looking into.
In dealing with microplastics pollution, I've heard the phrase capture technology. What is that?
Capture technologies essentially capture microplastics that are either being emitted at the source or are present already in the environment. Now, capturing microplastics that are already in the environment is very difficult because of the small size and nature of the microplastics. Some float, some can be at the bottom of the ocean floor. Their buoyancy changes as their chemical composition change over time. So that's very challenging. The other thing you can do is capture them at the point of emission. And there are several kind of companies that are looking into developing capture technologies, and some startups are running small-scale trials with examples include various filtration methods. There are players that are looking into magnetic separation or using adsorbents or coagulants to flocculate microplastics in various, for example, wastewater streams. But the key message is essentially at this stage, these are all very early stages of development. So they require a lot of investment and research to actually scale them so that they can be deployed at scale in a cost-effective manner.
You are working on microplastics capture technologies. What does that really mean if the plastic goes into the landfill? Are you trying to capture those little microplastic particles that do cause pollution?
So to correct you there, I'm not personally developing microplastic capture technologies, but a lot of people are. A lot of companies and scientists are looking into this area. There are two main ways of doing it. One would be, let's say you have microplastics that are in the ocean. You can develop technologies for remedial action, recapture some of those microplastics, which is very, very difficult for many reasons. But the other one is point source capture of microplastics. So let's say you have textiles industries, which can emit large amounts of microfibers into its wastewater streams. Then you can have capture technologies that can remove the microplastics from the wastewater before it enters the environment, essentially.
There's an effort now to make alternatives to plastic, to use biodegradable materials. But even biodegradable plastics require special treatment to biodegrade, to compost, require sometimes industrial composting facilities, and even biodegradable materials don't always survive and work in cold ocean, oxygen-poor, deep ocean environments where the degradation rate for these materials, like the biodegradable polymers, don't work. What I'm trying to having you explain to us is what's a biodegradable alternative to the microplastics?
Again, good question. There's a lot of attention on biodegradable plastics, and that's especially in Europe, or as alternatives to primary microplastic products. You have examples where you have agricultural companies that are developing biodegradable seed coatings, for instance. And that's because the EU regulation, that is the REACH regulation, that's looking to phase out primary microplastic, don't classify biodegradable polymers under the microplastic category. So that's what's driving the kind of momentum towards biodegradable solutions. But the problem is, it's as you've described there, that biodegradation process for most of these biodegradable alternatives, it requires special conditions or special environment and process conditions to actually degrade completely. In which case, under, for example, cooler ocean temperatures or in the soil, you may not get a full breakdown of the plastic. Again, you end up with this problem of microplastic generation. So we need a lot of data and information on the mechanism through which these biodegradable alternatives actually function under real-world conditions.
Biodegradation is basically a process of metabolizing polymers by microorganisms into water, CO2, and biomass. Can you define what a polymer is and a microorganism is and how that biodegradation process works?
I can certainly attempt to. So polymers are essentially long carbon chains. They constitute plastic. So they're made from individual building blocks like monomers, and in polymeric reactions they form these long chains. The reason why plastics are so popular is they don't break down easily. Then you have biodegrade, so that creates an environmental problem. But the biodegradable plastics, they can be more easily broken down by microorganisms that can cleave the bonds, the carbon-carbon bonds, in those polymer chains to accelerate the breakdown process.
What exactly is a polymer?
A polymer is a long carbon chain. So if you imagine you have monomers, those would be in smaller building blocks. You then form a long chain of those monomers. That makes the polymer. So they're long chains of individual building blocks.
Do you think that there can be more biodegradable polymer alternatives, plastics, to mitigate persistent microplastics?
I think potentially, but this needs a lot of research, a lot of data to actually gain information on how biodegradation works under real-world conditions. So there's a lot of focus on biodegradable polymers that need special conditions to break down for industrial composting facilities, for instance. But how they actually perform under real-world conditions, there isn't a lot of data on. So this is when we need standards that define what biodegradation looks like under given conditions. You can then actually design polymers or plastics that are suited to each operational condition.
And we're going to talk more about microplastics and how they are being handled when we return in a moment with my guest, Dr. Shababa Selim.
Environmental Directions with Nancy Perlman continues with further discussion of the world's critical ecological issues. For more information, you may call 310-559-9160 or go to www.ecoprojects.org. Now, Here's Nancy.
I'm speaking with Dr. Shababa Selim, who is a senior technology analyst with ID Tech X. Your company provides a lot of research for other companies so that they know how to proceed in the development of their products. Your report focuses on regulations, technologies, and alternatives for microplastics. Is the plastic industry trying to find alternatives, or are they happy the way it is? Are they working with you, or are you working with companies that are trying to develop other materials to replace plastics?
I mean, we certainly have a lot of companies that are interested in sustainability and improving their sustainability credentials. We do get a lot of companies coming to us to learn about technologies such as chemical recycling or more sustainable materials. But I think in many cases, you need to make a case for a company to actually want to look into alternatives. So there needs to be a cost benefit to it. There needs to be a regulatory driver to do it. So that incentive needs to be there.
Are you engaged in the field of regulation for these various products? Do we need more regulation to control microplastic pollution?
In terms of regulation, we have evolving regulations around macroplastics, so the larger plastics. But for microplastics, it's still not very mature. But it is evolving. So, for example, there's a lot of drive within the EU, the European Union at the moment, to tackle the microplastics problem. Globally, there's some regulations. 5-10 years ago, there was a lot of kind of momentum to ban microbeads in toiletries like toothpaste and various other over-the-counter products, but it's kind of stopped there on the global landscape. But the EU has kind of taken it forward back in 2023, where it introduced the REACH regulation to phase out microplastics across a range of different products over a 10-year period. That's one area where the European Union has a lot of momentum, and it's also looking into other sources of microplastic pollution. So another one is, for example, plastic pellets. These are what you'd consider the starting material. So they're also known as nurdles. They're starting material they can be, melted and molded into the plastic products that we see in our daily lives. But the manufacture and during the transportation, storage and processing of these nurdles or plastic pellets, there's a lot of loss and leakage into the environment. So there's currently a proposal in the EU to tackle plastic pellet losses across the supply chain. And then you also have microplastics in drinking water. So this is another area the EU is looking into, where it's introduced a methodology to measure microplastics in drinking water supplies. So based on that, it will be decided whether microplastics are added to a watch list across the EU. And I think in the US as well, you have some states like California that are also looking at methodologies to measure microplastics in drinking water and other areas. But certainly there's no federal movement to look at microplastics in drinking water or various other areas in the US.
It's great that the EU, the European Union, wants to deal with the microplastic pollution, but they're giving it 10 years to do more. It seems like we don't have that much time with all the pollution in the environment, that we should have these goals being reached in the next 2 or 3 years. Is that possible?
In an ideal world, certainly we would want that, but it's very difficult because they're used so widely. It's very difficult to replace them because they are very functional, and in many cases we don't have other viable alternatives to actually replace them with. So the phased out over the next 10 years process kind of takes into the consideration of whether you have alternatives that are available, or if not, how long it would take to actually develop them and replace them.
What is your definition of sustainable? What is a sustainable alternative versus what we have now? Is it something that will biodegrade within a year instead of hundreds of years or thousands of years?
I think sustainability, it depends on the context within which. Ultimately, for something to be sustainable, it means that it wouldn't cause harm to future generations.
Conservationists, environmentalists are constantly talking about sustainable alternatives. We need something that will be healthy, non-polluting. Is sustainability the same in every industry?
At the core definition of sustainability is to not cause harm for future generations. So that would involve using alternatives or materials that don't leave a permanent mark in our environment, whether it be pollutants or persistent chemicals. So that's one of the things about, in an ideal world, using biodegradable alternatives, they wouldn't have a footprint in the future because they would just degrade in the environment. But we just need to find alternatives that actually do that, do not persist. But that requires a lot of research in that space and a lot of data as well to actually understand the mechanisms through which that degradation happens.
Since a lot of your research is involved with materials, what are you looking at as a chemist in terms of sustainability?
Excellent question. When I see new materials or if I come across something, I'm very interested in understanding what constituent elements form it and also what its functionalities are. How much does it cost to manufacture it? So quite often also the journey through which it has been through to actually reach commercialization. So a lot of these materials that I work with, they were probably discovered or invented several decades ago, or in some cases 100 years ago. But it's only when you have a killer application does it become feasible for the drivers are there to actually bring it to market and for it to be adopted for other applications. I like kind of learning about the journey a material has been through.
Your company obviously is doing research for many different industries. What are you also looking at, and what are some of the other reports?
Yes, we look at a lot of different emerging technologies. We do market sizing, market forecasts, and a lot of the information we gather is actually by speaking to companies directly at events. But we have a large footprint in the sustainability space, so we look at things like biomanufacturing specialty chemicals, looking at bioplastics, carbon capture technologies. In addition to microplastics, we also have a portfolio and PFAS treatment technologies. But aside from that, other technologies we look into include hydrogen, electric vehicles, batteries and energy storage. Advanced materials, as I mentioned earlier, is an area I'm active in, but also semiconductors, computing and AI. So it's a wide range of technologies. So if you're interested in learning more about what we do, then do visit our website, idtechx.com.
Who's paying for all this research?
We conduct market research, and essentially our offerings are in the form of market reports that are purchased by companies or players that are interested in that research. Or we also offer a subscription platform where all of our latest insights are available on our portal. So through that subscription, companies have access to our forecasts, our event overviews, and various research in all the different areas we look into.
Your company has created a report, Microplastics 2025 Regulations, Technologies, and Alternatives. It has so much valuable information.
So we published a report on microplastics earlier this year that provides a comprehensive overview of the regulation across the different regions, looking at EU, US, and also globally, looking at the different capture technologies. You can access the report at www.idtechx.com/microplastics. So microplastics.
And of course, you have many other reports there, lots more information. I just want you to briefly summarize some of your other concerns, because you are a chemist by trade. You've worked with advanced materials for many different kinds of products. Can you tell us what some of these other new innovations are that you're looking at?
Yeah, sure. As you say, I'm a chemist, and with IDTechX, I have the pleasure of looking into a wide range of topic areas. So these include primarily the advanced materials space. One of the key areas I look at is metal organic frameworks. So some of you may be aware of this. So these are materials that were introduced around the early 90s and won the Nobel Prize for chemistry this year. So they've got a lot of attention on them at the moment, and there's been over the years many attempts to commercialize them, but they're now starting to find real-world applications, one of them being carbon capture, capturing carbon dioxide as part of, point source and direct air capture technologies. They're also used for, chemical separation or gas storage, and they have a potential for a wide range of other applications which are in development at the moment. Other materials I look at include aerogels, They are ultralight materials. 90 to 95% of them is air by volume. So they're very light, but they're also very good at insulating. They're used as fire protection materials in electric vehicle batteries. They're also used as insulation in industry, in oil and gas and energy applications. They also have a wide range of applications.
You're looking at a lot of different materials, which brings me back to the question of microplastics and alternatives. How do we phase out so much of the plastic that we are using? Because I see pictures all the time of wildlife who have starved to death because they eat plastics thinking it's food, and they have chemical elements in them. I don't know how healthy it is for any form of life. Are the alternatives basically from oil-based products, or are they from trees or plants? Or can we get the chemicals necessary from nature and put it so that we have biodegradable products that are healthy?
The answer to that can be very long and complex, but I think the long and short of it is, to tackle this, we need to tackle plastic pollution. That involves, one, minimizing or reducing the amount of plastic we produce globally. Two, it's also having more circularity, recycling and reusing plastics is really the way forward. Those are the two main ways of doing it, and we had hopes for a global plastic treaty that could potentially lead to act as an instrument for us to tackle this issue. But of course, talks for that reached a stalemate earlier this year, which was rather disappointing. So it boils down to individual countries at the moment to tackle this issue. And then when it comes to alternatives, as I mentioned, you have biodegradable plastics, which still may have the persistent microplastic issue. We don't have a lot of data on that yet, so that remains to be seen. But in some cases, the functionality of primary microplastics, those that are intentionally added into products, can be replaced with inorganic, mineral-based additives as well. They're not often as functional as the microplastics used, or they can be more expensive, or they're less developed. So that whole ecosystem needs to develop and target the replacement of microplastics in products.
Environmentalists have been advocating for biodegradable materials, but yet there's still a lot of research that needs to be done. Your company is testing biodegradability in a wide range of environments, from soil, seawater, compost, landfill. It's sort of different, and you have to define criteria for biodegradability. You have something like biodegradable mulch for films used in agriculture that are intended to biodegrade in the soil, but they require a greater or equal to 90% conversion rate of organic carbon to CO2 over a period of 24 months. It gets rather complicated. It's not so simple just to develop an alternative, is it?
No, absolutely not. Just to clarify, IDTechX, we don't do the research in terms of finding alternatives. What we do is we look at what the market is doing and provide our assessment in our reports based on that. So we look at what technologies are coming to the fore. On the topic of what you mentioned, it's biodegradability. I mean, essentially, what is biodegradability? If you ask that, all plastics are biodegradable, but you have to define the time span within which it degrades. Most plastics require hundreds of years to degrade fully, which is, in the traditional norm, we don't call it biodegradable. But the ones we are referring to as biodegradable usually have a much shorter time span during which it degrades. So those time spans, the conditions needed, for example, what process, what temperature, do we need a certain amount of humidity, all of these, you need kind of standards that define the criteria for biodegradability for each kind of condition. The one you mentioned on the biodegradable mulch films, so that is, I believe, referring to the standard EN 17033 2015. That essentially stipulates that for it to be classified as biodegradable, then it needs to have over 90%, the organic carbon has to convert into CO2 within the temperature range of 20 to 28 degrees and a time period of 24 months. This is what these standards do. They define the conditions, the criteria under which you can say that this material is biodegradable.
It's not a simple problem to deal with, and it's much more complex complex, but you've certainly given us a much better understanding of what's going on in the field, what kind of research is going on, what more we need to learn to deal with the microplastic pollution. I want to thank you so very much for doing the work that you are doing, and thank you for being my guest.
Thank you very much for having me on your show, Nancy. It's been a pleasure talking to you.
I have been speaking to Dr. Shababa Selim, who is the Senior Technology Analyst with ID Tech X. I'm Nancy Perlman. Thank you very much for joining us, and do tune in again next week.
If you would like free information about these environmental issues, go to www.ecoprojects.org or call 310-559-9160. Environmental Directions with your host, Nancy Perlman, is a community affairs program of the nonprofit organization Educational Communications and this station.